semiconductor industry was the second example. So in this example, we were approached by a founder who, again, had an idea of market space with an inkling towards technology. In this case, the entire space was really data storage. And there's different kinds of data storage. There, as you may know, there's permanent data storage. There's, read-write. And within these categories, there's things like, DRAM, SRAM, etc. So these are just different kinds of technologies, and there's disk storage as opposed to, so there's different kinds of data storage markets. I've labeled these as technologies because in this world, that's how the markets are labeled. But I'm putting them in the market circle over here because I'm talking not about the technologies themselves, but about the markets that people tried to feed into. So, for example, I could have a different technology that would change the way that dynamic random addressable memory is done. And same thing with SRAM or disk storage or whatever. So not to be confused, because obviously there's original technologies in silicon, for example, that feed into SRAM and DRAM. And there's different kinds of technologies that feed into read-write or permanent storage, but they're all very specific markets because these are really subunits that fit into other markets like computers and network storage and things like that. So anyway, there's a big market over here. One of the things that the founder had said is, hey, when I look at CD-ROMs, I see permanent storage, but wouldn't it be nice if I could electrically address it? And so if I could merge the two worlds, I could have, let's say, a plastic disk that if there was some way to do it cheaply, we could have lower cost memory. So it turns out one of the tough categories that they were looking for was, low cost memory that had a unique space, and without any specific detail, they were thinking towards, again, sort of this hype days. This particular company is founded about 2004, 2005, and looking towards, this sort of technology space, saying, what can save us over here? So the original ideas were that, hey, CD-ROMs or, DVDs essentially, they're made, if you think about music and all that, they're made from punching out things in DVD technology itself. So in other words, you have like a disc, and what happens is it's got plastic and metal, and then pins come down, and where you want to have a 1 or a 0, it makes a divot, and then when later you read it with light, the reflectivity is different in a place where there's a divot or not. And so all those little divots represents 1s and 0s, and the idea is, well, what happens if you could use that manufacturing infrastructure? So now we're jumping down here, and in the different infrastructures, there's what we call the traditional silicon manufacturing infrastructure. What the founder was really doing was inserting new kinds of infrastructure. He was thinking of DVD infrastructure and saying, could we use that infrastructure for creating new kinds of memory that would be cheaper than using silicon? Because even though silicon has really reduced costs drastically, there was a probably imprecise idea in the marketplace that memory can't drop fast enough in price because we're got all that expensive semiconductor equipment. Actually, the truth is that all of that is optimized for the lowest cost possible price per bit. But the idea was that somehow, because these are, if you think about the CD-ROM DVD, when you print it, it's a write once technology. and they weren't fully appreciating the differences between write once and creating, sophisticated electronics that could be, rewritten many times like DRAM. But it is reasonable to say, hey, is there space where we can switch manufacturing, kind of find some, ability to use DVD infrastructure, but make things that are multiple read-write, cycles. And so we started thinking about many different kinds of things that were used in manufacturing. So even the magnetic disk industry, they have their own manufacturing infrastructure. And so all these things were put on the table initially because the idea was that we're going to get out of the boxes that these markets traditionally had feeding into them, and if we could just open up, we could get combinations where we could use cheaper infrastructure to build, read-write memory. So you can see over here, in this case, what was interesting is the founder came with the market and implementation circles filled up, although, again, at an abstracted level like they should be. But a lot of the details in the technology piece are left out. Now, the founder had tried to create certain technologies by saying, all right, what I'm going to do is, if I want to be on plastic, then physics automatically means that I have to look at things like amorphous materials, it turns out, because when I deposit these materials on plastic, I have to do it at low temperature, and they tend to be amorphous. And so what happens is you end up with amorphous thin films, which means that then you're going to have, amorphous devices. For non-materials people in the world here, amorphous just means that the materials have no crystal structure, and it kind of moves into a more a less investigated area. It turns out certain kinds of amorphous materials have been investigated quite heavily, but in general, it's let's say that most semiconductors that are in your computer and things like that are crystalline, so it's a much more advanced and well-researched area comparatively speaking. So, when faced with this, one of the first things we did was say, where is the real advantage? And actually, one of the key things which ended up being an important factor that I looked into very early was circuit design. The reason being is that all this is nice, and you're at a very high level thinking about how you're going to change things fundamentally, but at the end of the day, it's a circuit that is the vision that was desired. It's trying to make a cheap plastic CD-ROM or DVD or something that was electronic essentially instead of optical, right? That you could address it electrically. And so really in iteration on the first pass, one of the things I found in implementation actually was a particular patent that the original founder, had created, that was really one of the key things, because what it allowed you to do was it allowed you to build the circuit for the first time in a different way, and it implied that you would have very few mask levels. So one of the things in the first iteration was that this patent started to become a focus, and as we iterated and we looked at the details in the technology, we started to realize these amorphous devices were key, amorphous materials and devices, but actually this circuit design that was in this patent was one of the key things. And so we ended up realizing that the DVD infrastructure was not that important, it turns out, and that if you looked at reducing the number of mass levels in the silicon manufacturing infrastructure, it turns out that that would reduce the cost of memory itself. So even though we started off with this world, we're imagining plastic discs and everything else, after the first iteration we ended up converging on one particular kind of circuit. So all the other patents that they start off with were really not valuable. And in there we had these amorphous devices. And then in implementation, the most important thing was the patent portfolio and actually silicon infrastructure, which was, you know, poo-pooed at the beginning of this process. But for a startup, we could access this infrastructure cheaply and build products that initially were not that expensive. And we were still within the concept of low-cost memory. So what's very interesting in this first pass, again, you can see how this iteration works. A lot of the concepts that were kind of thrown around, and it's okay because, you know, for a little while anyway, you want to leave these areas open, and you do want to think about a lot of technologies, and you do want to think about, hey, could we make memory, popping those things out of the DVD infrastructure like they were disks, right? And, you know, we would love to you know, address all these different markets, but you know, that's the thing that didn't change too much. The path that we were on pretty much remained the low-cost memory, and the idea that we were going to beat the high end of any of these markets was not going to work. So these all got thrown out, and you're left with, you know, a pretty focused low-cost memory. And so the company then converged on the one path that made sense, and we could access silicon infrastructure because we could borrow time on you know, existing infrastructure. So it also, in implementation, really focused on that, and the intellectual property became a very important part. And we were probably going to license that. It turns out that this invention, at the end of the day, did not work. It turns out that this circuit topology ended up having just too much current run through it, actually. And you know, our circuit designer may or may not have caught that earlier. You know, this is always hindsight, but the truth is that you know, when the first prototypes started coming out, there were some quick fixes, but at the end of the day, it did not converge. And so you know, this original set of ideas that we had here, you know, converged down to a very interesting area that could have worked. But at the end of the day, because the final innovation had some physics that just couldn't happen, indeed, at the end of the day, it did not converge. But the point of this is that this process actually worked and brought this down to the best possible potential direction within the funds and time and everything. And unfortunately, it didn't converge, but it was a hopefully that gives you an idea on how these different areas interact. So next time we'll come back and talk about, in these processes, you'll notice that I talk about going back and forth between these different areas. I'm leaving out a lot of details, because how do we get that information? How do we know that, you know, silicon infrastructure is available? Or how do we know that DVD is less expensive if you can really just print those things? And so the question becomes, you know, how do you actually get that information? And so next lecture we're going to talk about transactional experiences, which are the missing glue in terms of actually doing this process.